We are going to work on 10.3, and it's simplifying radicals, the distance formula, and circles. I would like you guys to make sure that you read all of the notes. I'm going to go over just the examples. This is the product rule. Remember, whatever's under the radicals are multiplied together, and their indexes must be the same. So the first one, it's the square root of 5 times the square root of 13. What you're going to do is you're going to multiply 5 times 13. I don't even know what I just said a minute ago. The square root of 5 times the square root of 13. That is going to give you the square root of 45, right? 65. All right. If you're ever in doubt, just use a calculator. 5 times 13 is 65, right? So 15, yes. All right. And you guys, I don't think I can simplify square root of 65. It would just be the square root of 65. Now, letter B, it's going to be the square root of 7 times xy. There is no way to simplify any of them. So whatever's under the radicals can be multiplied together. Whatever's outside the radicals can be multiplied together. Now, remember the indexes must be the same. Otherwise, you cannot multiply what's under the radicals together. Now on this problem here, they're both cube roots. So it's going to be the cube root of 2 times 7, which is 14. And you cannot reduce the cube root of 14. Same thing here. It's going to end up being the fifth root. 9 times 8 is 72. I should do the x's first. X times x is x squared. And y to the second times y to the second is y to the fourth. None of these have have exponents that are larger than 5, so I can't reduce it. I'm not 100% about 72. I'm just going to double check something real quick. 36 times 2, 6 times 6, 2 and 3, 2 and 3, 1, 2, 3. Yep, I don't have, so there's nothing I can do. I can't simplify it anything. I wasn't for sure on that one. Now the next one's going to be the sixth root. So I get 8 times 2, which is 16. R squared times r to the third is r to the fifth. Remember, when you multiply powers, you add the exponents. Now on this one, I think I can do this. I'm not for sure though. 2 times 8, 2 and 4. 2 and 2, that's 1, 2, 3, 4. Nope, it doesn't give it to me. I need to have 2 to the fifth power, and it only gave me 2 to the fourth, so I can't simplify 16. I thought I could, but I can't. Now this one's a little different. The radicals do not have the same index. So this is going to be 7 to the 1/2 times 5 to the 1/3. Now, I cannot use the rules for exponents because my base is 7 and the other base is 5. So there's really nothing for me to do on this problem. I could make them have the same base. I could manipulate it if I need to. I could multiply this by something that would give me a 3 in the denominator. I don't know how much this would help me, but I'm just going to try playing around with it for a minute. And if I multiply this by, let's say, 2/3, so I would get 1/2 plus 2/3. I don't think this is going to help me at all. And my denominator is going to be 6. Times that by 3, times that by 3, that gives me 3, times that by 2, that times that by 2, that gives me 4, so that gives me 7/6. So if I multiply this by 7 2/3, this gives me 7 7/6. My goal is trying to get it all to have the same index, okay? So by multiplying this by 2/3, I just picked 2/3, you guys. I could have picked 1/3, and I just realized I probably should have picked 1/3, but it's fine. I just multiplied it by 2/3. Then if I multiply this side over here by, let's just say 5 2/3, okay? So that's going to give me 1/3 plus 2/3. Actually, I fibbed. I should do maybe 1/2. Let's do 1/2. I forgot I need it to be 6. So then this is going to be 6 times that by 2, times that by 2, times that by 3, times that by 3. And that's going to give me 5 6. 5 to the 5 6. And you guys, all that this does for me is it's going to be the 6th root of 7 to the 7th power times 5 to the 5th power. And by the way, I could take out a 7. So that could also equal 7 to the 6th power of 7 times 5 to the 5th power. However, you could just say you can't simplify that, and that's it. That's all your answer would be. You could just leave it like this if you want to. I just was playing around with the numbers. I don't know why I was playing around with the numbers. You can kind of manipulate it to where you could have, I probably shouldn't have used 2 to the 3rd. Let me see if I can just make this something a little simpler, just to kind of make your lives a little easier. And I should have. And they don't have the same index, so this is going to be 7 to the 1/2 times 5 to the 1/3. You want these to be 6s. So we're going to have 7. So 1/2 plus 1/3 gives me 6. That's 3. That's 2. So that's going to be 5 6. And then times 5. We're going to do the same thing over here. That's going to give me, should also give me 5 6. So you end up with the 6th root of 7 to the 5th times 5 to the 5th. That is one way to write it. You can't simplify it any further. However, you could just leave it alone and never touch it whatsoever, and just leave it as the square root of 7 times 3 square roots of 5, because you can't simplify any of that. Okay, so it's kind of useless to do all that because there's no simplifying. So just forget that problem. All right, you guys, we're going to do the quotient rule for, just remember you divide, when you divide powers, you subtract the exponents. Again, they need to have the same root, okay? The square root of 100 is 10. The square root of 81 is 9. You guys, you cannot square root 11, so that's just the square root of 11. You can square root 25, that is 5. Now the cube root of 18, at this moment, I can't think of doing anything with that, but the cube root of 125 is 5. Now, 18, I know that, no, there's nothing I can do with the cube root of 18. It's just going to have to stay there. If I had 18, 2 times 9, that is 3 times 3. There are no numbers that are repeated 3 times, so it doesn't help me. That's just left alone like that. This one here, I have the square root of y to the 8th. Since I have a square root, I need to have a 2 on the bottom, or on the top actually. So I'm going to rewrite this one. The square root of y to the 4th raised to the 2nd power. And the reason why I did that is really y to the 8th. That's exactly what y to the 8th is. Because it's a square root, I wanted this to be a 2 on the outside. Now, the square root of 16, we know what that is. So here we go. The square root of y to the 4th squared is y to the 4th. The square root of 16 is not 8. It is 4. All right. Now for the bottom one. The negative is on the outside of the problem, and we are going to do the cube root. You can't cube root x squared. That's just the cube root of x squared. But you can cube root r to the 12th. I can rewrite this as, because it's a cube root, I need a 3 on the outside. R to the 4th raised to the 3rd power is really R to the 12th. So what you would end up with is the negative is on the outside. I cannot take the cube root of x squared, but I can take the cube root of R to the 4th to the 3rd power. Whatever's being raised to the 3rd power comes out. So the R to the 4th power comes out. Okay, let's try another problem. Simplifying radicals. Let's just keep going. So I want you guys to look at these, and the key is, if you have a radical in the bottom, you've got to get rid of, rationalize the denominator. But right now we don't have any fractions, so we're okay. Now, when I'm trying to simplify the square root of 32, what I always do is I think of a perfect square root times something that gives you the square root of 32. First of all, the square root of 32 is 4 times 8, 16 times 2. I always try to pick the number that has the largest perfect square root. So I'm going to pick 16 and 2. The square root of 16 is 4, and I cannot square root 2. Now, another way to do this problem is to take all your primes. 32 is 4 and 8. 4 is 2 and 2. 8 is 2 and 4. And 2 and 2. So 32 is also equal to 2. There's 1, 2, 3, 4, and 5 to the 5th power. So another way to do this would be to the square root of 2 squared raised to the 2nd power, because that's going to give you 2 to the 4th power, times 2. Now, when you square root 2 squared to the 2nd power, the 2 squared comes out, times the square root of 2. So you end up with 4 square roots of 2. I personally like to use perfect square roots. I think it's quicker, but I wanted to show you guys both. Same thing here. I would find the largest perfect square root times 3. That gives you 300. The square root of 100 is 10, and I cannot square root 3. So these are simplifying them. If you wanted to use, like I did over here with the factor tree, it would be 3 times 100. And this would be 10 times 10. I would actually leave it like that, and I would just say the square root of 10 squared times 3. The square root of 10 squared is 10, and I cannot square root 3. So that is another way to do it if you want to. I personally wouldn't. And by the way, the square root of 35, there's no perfect square root. You can't simplify that one. You would just leave it alone. And by the way, with my crazy numbers, you would just leave, where'd it go? You would just leave this alone. So I'm going to do that. All right.